Hey guys, today we're going to have a look at the areas of composite shapes. Now these are the extension problems, so don't expect this lesson to be easy. But I've been seeing a lot of memes lately of things like this where your classwork is super easy, your homework is getting quite a bit harder, and then you get to an exam and you have no idea what you're being asked. Well, I'm not going to let that happen to you. Today we're starting with these questions, and hopefully your classwork and your homework will be a lot easier. Let's start with this example here. Now you should recognize this diagram because we have seen it before, but the information I'm giving you is slightly different. This time I'm giving you the fact that the area of the rectangle is 3 times the area of the triangle, although I'm not telling you what either of those are. And I'm asking you to work out the height of the triangle. Now don't do what students always do, is they look at what they're asked to find and they try and find that answer right away. You won't be able to do it. Start at the beginning. I'm giving you some information. Let's write an equation about that. Given that the area of the rectangle is 3 times the area of the triangle, the area of the rectangle is equal to 3 times the area of the triangle. That's exactly what you've been told in the question. I'm just putting it into an equation for you. Don't jump ahead. Let's move forward with where we are right now. We know the formula for the area of a rectangle, and we know the formula for the area of the triangle. So let's substitute those formulas into this equation. The area of a rectangle is length times width, and the area of a triangle is base times height divided by 2. So the area of the rectangle being 3 times the area of the triangle means that the length times the width of the rectangle is equal to 3 times base times height divided by 2. Now we do know some values here, so we could substitute some values into here, but it won't be quite enough to work out directly what we're looking for, which is the height of the triangle. But let's substitute in what we know. We know the length of the rectangle. It's down here, is 12 centimeters. We don't know the width of the rectangle. We know the base of the triangle. It's the same as the length of the rectangle. They should both be 12 centimeters. But I don't know the height of the triangle. So now I have an equation here, and you're thinking maybe we can solve that, but not so long as we've got two unknown variable values. I don't know what the W is, and I don't know what the H is. Now I'm trying to work out what the H is. The W is something I'm going to have to find by default as I'm working it through. So to be able to solve this equation, I want to start by replacing the W with some value or some expression that's going to make the equation easier to solve. So I'm going to start by using an expression to represent the W. Use expressions in terms of the variable we must find to represent the values we don't know. So I don't know what this W is, but I'm sure I can write some kind of an equation that's got W and H in it so that I can replace the W with an expression using the letter H. Now, W and H, the width of this rectangle and the height of the triangle, they should together add up to that total length of 18 centimeters. So I've written that here. The width of the rectangle plus the height of the triangle equals 18. So now, so that I can replace the W with some expression with the letter H in it, that way I'm going to have an equation with just H's and numbers so I can solve to find out what H is. So getting W on its own, I'll send H to the other side. W is equal to 18 minus the H. And now I can use that expression instead of the W. So instead of having 12 times W, the length times width of the rectangle, is equal to 3 times the area of the triangle, I can do 12 times 18 minus H because that's what the height of this, or the width of this rectangle will be. If I take away the height of the triangle, that's what I'll have left over. Right, now I've got an equation and it only has numbers and the letter H in it. So now that we have an equation with only one unknown variable, we can simplify and solve the equation. So I'm going to go ahead and multiply this through 12 times the 18 and 12 times the minus H. And I'm going to simplify what I've got in these brackets here before I multiply that answer by 3. 12 times 18 was 216, and 12 times the minus H was minus 12H. And over here, I've just done 12 times H is the same thing as 12H, which of course I can now divide by 2. 12H divided by 2 is 6H. We've got 18H And I've got my h's together by taking this minus 12h over to this side, making it plus 12h. That together will make 30h. So I've got 216 still on the left-hand side and 30h on the right-hand side. Remember, we're trying to find out what h is, so we got to get h on its own. 30 is being multiplied by the h, so we'll take the 30 to the other side and we'll divide by it. So we've got 216 divided by 30, which means h has got to be the 7.2. So our height of our triangle is 7.2 centimeters. Now that was a lot of working there, and at the very beginning you may not have known quite how to start, but if we go back to the very beginning, we can check if our answer is correct. Check if the height of the triangle is actually 7.2 centimeters. If that's the case, then the rectangle area will be 12 times, remember this height here? That is the full 18 minus the height of the triangle. So it's 12 times 18 minus 7.2. Simplifying that, 18 minus 7.2 is 10.8, and 12 times 10.8 is 129.6 centimeters squared. We're not done. What we're trying to prove here is what we were told at the very beginning, that the area of the rectangle will be 3 times the area of the triangle. So I've got my area of the rectangle. Let's see what the triangle area will be. Remember, the triangle area is base, which is 12, times the height, which we worked out, 7.2, divided by 2. And that works out to be 86.4 divided by 2, which is 43.2 centimeters squared. Now, is that rectangle area 3 times this triangle area? 3 times 43.2 should give you 129.6 centimeters squared. Okay, example 2. Check out this composite shape. It's really complicated. I don't think I would ever give you a shape like this without giving you a little bit more help. So, if we want to work out the total area of the shape, you must be able to break this down. There, I've given you some different colors so you can see that this shape was actually made up of a rectangle, a parallelogram, and a trapezium. And I've given you some more information here as well because that wouldn't be enough either to work out the entire area of the shape. The rectangle has a perimeter of 26 centimeters. Okay, that looks like I've got some work to do there. The area of the parallelogram is 5 times the area of the rectangle. Oof, I don't know the area of the parallelogram or the area of the rectangle. And the trapezium is an isosceles trapezium. Okay, that kind of looks like it could be a isosceles trapezium. Work out the total area of this shape. Now I'm sure that some of you seeing this are overwhelmed, but let's take this one step at a time. Starting with the rectangle. It has a perimeter of 26 centimeters. So if you know that the total perimeter is 26 centimeters and you only have one of the lengths there, you should be able to work out the other lengths. So let's start with the formula. If you're given the perimeter, you should start with the perimeter formula. The perimeter of a rectangle is 2 lengths plus 2 widths, and that should be equal to 26 as we're told. We know the length is 8 centimeters, so that should mean that 26 is equal to 2 lengths, that's 2 times 8, plus 2 widths. Now this can be simplified. 2 times 8 is 16, and I want to solve this equation to find what the only unknown value in this equation is, the width. So I'll get the width on its own, starting by moving the 16 to the other side. Here it's plus, so there it will be minus. 26 minus 16, that's 10, and that's equal to 2w. So w on its own, I'll need to take the 2 across to the left-hand side. It was multiplying, so now it's dividing. W is equal to 10 over 2, so w must be 5. The width of this rectangle is 5 centimeters. Okay, that's not exactly what we were asked to solve, but that must help. I hope you started by drawing a diagram because we're going to label it with all the information that we've got, and that's going to help us to solve. Remember, don't jump ahead and try to solve without following these steps. Next step we're told is that the area of the parallelogram is 5 times the area of the rectangle. Okay, we now can work out the area of that rectangle because we know the length and we know the width. And the area of the parallelogram, well, we know that the base of it, and I'm calling this the base because I can then work out the perpendicular height to it. The base is 8 centimeters. So let's set out another equation. Starting with the formula for the area for the parallelogram, which is base times height, that parallelogram is 5 times the area of the rectangle. So I'm going to do 5 times the area of the rectangle is equal to the area of the parallelogram. Right? I know the rectangle has a length of 8 and a width of 5. If I multiply that by 5, that'll give me the full area of the parallelogram, which is otherwise calculated by doing the base of the parallelogram, 8, times the height of the parallelogram, which is the thing I don't know. So simplifying that, 5 times 8 times 5 is 200, is equal to 8h. I want to know what h is, so I need to get the 8 to the other side. The 8 is multiplying, so I will do 200 divided by 8. And that tells me that h is equal to 25. The height of the parallelogram is 25 centimeters. Okay, we've got a lot more information now on our diagram. It's still not enough to completely solve, but it will help. If this trapezium is an isosceles trapezium, that means that we've got some symmetry here. That means that this side length here is equal to this side length here, and this angle here is equal to this angle here. But it also means that if we cut this trapezium perfectly in half, the length on this side of it will be equal to the length on that side of it. That means that if I know that this is already 25 centimeters, the height of the parallelogram, that should lie along part of this length of the trapezium. And that length there is symmetrical. It's equal in length exactly to the length from this vertex to where we're lined up with the vertex up here. So that's also 25 centimeters. And in between here, well, that's all lined up with this rectangle, which is 5 centimeters in length there. So it'll be 5 centimeters in length here, and that will be 5 centimeters in length there. So we know this full length. We know this length in here is 5 centimeters, and we can work this length out as well, the height of the trapezium, because the whole height here, we're told, is 15 centimeters. This much of it is 8 centimeters. So 15 take away 8, we should have 7 centimeters left. Right, so now we can go ahead and set up the formula for the trapezium. The area of a trapezium is A plus B divided by 2 times h, where A and B are the parallel side lengths. So if I call this A or B, and I call this B or A, I'll add those two lengths together and divide by 2 to get the average of those two lengths. So we're treating this kind of like it's a rectangle, but we're not doing length times width because we've got two different lengths. We'll get the average of those two lengths. So we'll do 5, which is this length here, plus 55, which is this parallel side, which is much longer than the other one, divided by 2 times by the distance between them, the perpendicular height, which is 7. 5 times 55 is 60, so that's going to be 60 divided by 2 times 7, and 60 divided by 2, that's 30, so that's 30 times 7. So the area of the trapezium is going to be 210 centimeters squared. There we have it. We figured out the missing length in the rectangle. We know the area of the rectangle. We figured out the missing height of the parallelogram. We've worked out the area of the trapezium. We must be done. We're not. Always reread the question. We were asked to work out the total area of the shape. So to work out the total area of the shape, we know the area of the rectangle. It's length times width, which is 8 times 5, which is 40 centimeters squared. We know the area of the parallelogram. It's base times height. That's 8 times 25, which is 200 centimeters squared. And we've just worked out the area of the trapezium. It was that 55 plus the 5 divided by 2 times the 7, which was 210 centimeters squared. So having reread the question, I realized I've got a little bit more working to do. The total area is going to be the sum of all these areas. So that's 40 plus 200 plus 210, which is 450 centimeters squared. Now let's just go back over those steps now. Steps to facing composite shape problems. Copy the diagram, labeling everything you know. Even if you have no idea how to start by doing that because you're going to get a lot of understanding about the shape just by copying the diagram. Step 2, study the given information. If they give you the area, then think about using the formula for the area. If they give you the perimeter, think about using the formula for the perimeter. If they give you a side length or a width or a height or a base, make sure that that's labeled on the diagram. Set up the formulas. Now, once again, this depends on the given information. If they give you an area, the formula area for the area. If they give you a perimeter, the formula for perimeter. Then substitute into the formula to form an equation. If you are given values, or you are told that one thing is equal to another, or one thing is 5 times the other, substitute those values into your formula so that you can write an equation with only one unknown value that you can rearrange and solve. Next step, simplify and solve that equation. So do all the calculations that you can with the values that you've got. Rearrange that equation to get your variables to one side and send the numbers to the other side, and try and get the variable on its own to find its value. Finally, reread the question. I can't stress how important that is. You could have done all of your working correctly, but then given the wrong answer because you didn't read what was actually asked. So reread the question. And then check your answers whenever possible. If they told you that the triangle is 5 times the rectangle, go ahead and calculate, is that triangle area really 5 times the area of the rectangle? Check your answers whenever possible. And most importantly, take it one step at a time.